going to continue our focus on probability with this idea of an independent event or several events. These events are when one event is not affected by the other. For example, they mowed the lawn this morning. That has nothing whatsoever to do with the fact that I have a bug bite on my leg. Okay? They're completely independent events from each other. Okay? That's just one example. Whether you had gym class today or not is completely independent of whether or not you had lunch. Two completely different events, not related. So, example number one, we have a fair coin and we also have a die. We're kind of familiar with this idea. Are these two events independent?
Yes.
Yes, why? One does not, right. And then in letter B, they want us to draw a tree diagram. So I'm going to start with a coin since they listed that first. So I could get a head or a tail. And then on the die, I could get 6 different outcomes. And I wrote mine at the end because they had to be kind of squished together there. So, letter C, what's the probability of getting a tail when I flip the coin?
1/2.
Right, 1 out of 2 times, good. And in letter D, what's the probability of rolling a number less than 3? We could get a 1 or a 2, so 2 out of 6. Okay? Using our tree diagram, what is the probability that a tail is tossed and a number less than 3 was rolled? So we've got this tail and a 1 and this tail and a 2. Are there any other combinations of a tail and a number less than 3? No. So that's 2 out of how many? 12. Huh. Letter F. How could we use our answer from part C and our answer with part D to get our answer in part E?
Add up.
1/2 times multiply.
Say it again, Danny.
Just like multiply them.
Multiply them, so 1/2 times 2, 6 is equal to 2 12s. Yep. And that's it. That's the big story for our notes today. Anytime you have probabilities with an and, you're just going to multiply the 2 probabilities. That's our big news for today. The problem is that not every question's written as a tail tossed and a number less than 3. So we have to sometimes throw in that word and on our own. Let me give you an example. In number 2, a fair die is rolled 2 times. What's the probability that we'll land on a 4 each time?
136.
Well, I don't hear the word and in there anywhere. So what they're asking is the probability of a 4 and a 4. Right? They want to get a 4 both times. So what's the probability that we roll a 4 the first time?
1 out of 4.
1 out of 6, good. And what's the probability to roll a 4 the second time? 1 out of 6. And if we multiply those, like our little rule says, 1 out of 36 times will we get a 4 followed by a 4. It's not very good odds, right? You're right.
I'm confused.
What's the matter? Okay. Well, let's hold your confusion until we're done with a couple more on the back. Maybe with a little more practice it'll make sense. And then again, maybe not. So, the key to these problems is the word and. And again, sometimes it's missing. Number 3, Michael flipped a coin 3 times. And in each case it came up heads. Stop right there. I don't see the word "and" yet in that sentence. Okay, so it's the probability that he's going to get ahead on the first toss, and ahead on the second toss, and ahead on the third toss. That's the question they're asking without using the "and." So what's the probability that this will happen? What's the probability that he'll get ahead the first time?
1 and 2.
And the second time? And the third time? And straight multiplication. 1 times 1 times 1 is, and 2 times 2 times 2 is
8.
8.
This is the
The tricky part is finding the "and" that they're looking for. Number 4. Ava's taken a multiple choice quiz for which she has not studied. Bad, Ava. There are 5 questions on the quiz. And each question has 4 possible choices. Now, Ava, who didn't bother to study, happens to be looking for a 100. Most people are just looking to pass at that point when you haven't studied, but Ava's shooting for the goal. So, how many questions does she have to answer correctly? 5 of them. What's the probability that she's going to be correct, and correct, and correct, and correct,
How many times are we doing this?
and correct? 5 times, 1 for each question. Okay? What's the chance that she guesses correctly on the first question? 1 out of 4? Where'd you get 1 out of 4 from? Where'd the 4 come from?
You don't have one answer that is 4.
Because there's 4 possible choices. So each of these is a 1 out of 4. And we are multiplying.
So would it be 1 out of 1,024?
1,024.
So there's definitely good odds that she's.
Very bad odds. Please don't bet on Ava getting a 100.
If she
And
gets
she just guesses.
I'm not copying off her paper.
Yeah, good. Yep.
That's when you just choose C for every answer.
Number 5. Jacob consistently makes 80% of all of his free throws in basketball. Which of the following represents the probability that he will miss 2 free throws in a row? Hold on. It said that he makes 80%. How do I know what he misses?
20, add it.
Okay, yep. So the 100% minus the 80% that we know he makes leaves 20% that he misses. Okay, so we got that. Now he's going to miss 2 in a row. Find the probability that he misses and misses.
So 4?
So 20% times 20%. Now it's been a little while since we did percents.
So
20% is written as what decimal?
0.20.
0.2, and I'm going to switch to parentheses now, so we don't get my decimal point, my multiplication screwed up. So, do you remember how to multiply these? 2 times 2 is 4. And then what do I have to do about these decimal points? Move it over. So it was here, we're going to move it over 2 places. But, now I need to write it back as a percent. So times by 100. So choice 4. 4% that he's going to miss 2 in a row. Pretty low odds. Pretty sure we're not thinking that when we're standing on the foul line, everybody's watching us. But
Yeah, you should have doing your head on.
pressure's a little, yeah, let me do the percent.
Next year I modified.
There you go, yeah. All right,
Well, these are still some good ones.
our last question. Weather forecast states that there is a 40% chance of rain on Saturday and 70% chance of rain on Sunday. Letter A, what is the probability that will rain on Saturday and on Sunday? All right, and means we do what?
Multiply.
Multiply. apply. So chance of rain on Saturday is 40%. Chance of rain on Sunday is 70%. I jumped right to decimals on that. What is that probability? Okay, 0.28 or 28%. Letter B, what's the probability that it will not rain on Saturday or Sunday?
Let me just subtract that from 100.
No. Wait, what? Where'd you get 0.6 and 0.3 from? Oh, so the chance that it won't rain on Saturday is 60%, and the chance that it won't rain on Sunday is 30%. So 0.6 times 0.3 is about 18%. Pretty low odds, right? Letter C. Why don't our answers from A and B add up to 100%?
What? I'm confused.
If I add the 28 and the 18, because right, we covered everything. It's going to rain or it's not going to rain.
How did you get the percents for not raining?
We did 100 take away 40, and then 100% take away 70. Like we did up above with the percent shooting. What do you know over here? What do you know, Nick?
You subtract 100 both times.
Yeah. Yeah, no, yeah.
I think
Can I try to relate this to something that you might be familiar with? Okay. If it's going to rain on both Saturday and Sunday, that would be like getting a head and a head if I flipped a coin, right? It rained both times, or I was successful both times. If it's not going to do that, that would be the opposite. So getting two tails. Thank you. Say it again, Macy. Yes, we're missing the combination of it could rain one day, but not the other. So that would complete our 50 or our remaining 100%. Thank you. Oh dear. So the big message is look for the word and, or figure out what the and situation is, and then you're just multiplying those probabilities. I would guess that you may want your calculator for this homework, because some of the multiplying might get kind of big, like the this one up here, 1024 denominator. Okay?